Good evening everyone. Welcome to another lecture of engineering mechanics, and this is lecture number 20, kinetics of particles. We have completed the statics part of engineering mechanics, we have completed the kinematics part, and now we are moving on to the kinetics part, where we are going to deal with problems related to bodies in motion. But there is a difference between kinematics and kinetics. In kinematics also we dealt with bodies in motion, but there we were not considering the forces behind that motion. Here we are going to solve the problems by considering the forces acting on the body due to which the body is in motion. But before getting into that, let's solve the problem that I gave you in the last class as an assignment. A rod AB of length 1 meter is sliding in a corner as shown in figure. At an instant when the rod makes an angle of 20 degree with horizontal plane, the velocity of point B on the rod is 10 meter per second to the right. Find the velocity of the end A. So here the body is in general motion. We know the direction of velocity of point B and point A, right? Point B is going to move along this surface, so the direction of velocity will be like this, and point A is going to move along this surface, the direction of velocity will be this. So this is VB and this is VA. Now in order to find the I center, what we are going to do, we are going to draw a normal from point B, normal to VB, and then we are going to draw a normal to VA from point A, and the point at which both of these normals intersect is the I center. So this is your I center. Okay, so this is normal to this and this is normal to this. Now once you got the I center, you can calculate the velocity of A if you know the velocity of B. How? You can do this. You need to find the velocity of A, right? Yes. So VA is equal to omega into IA, right? And VB is equal to omega into IB. If I take the ratio, I will get VA by VB equal to IA by IB, right? So from here I can calculate the value of VA. Now we need to find IA by IB. So how we can find IA by IB? Understand here. See, this angle is 20 degree and this is 90 degree. So we know that this angle is going to be 70 degree, right? Then this angle is 60 degree. Look at this. This angle is 60 degree. So this angle is going to be 120 degree. 180 minus 60. Now this is 20. This is 120. So what will be this angle? 180 should be the sum of these three angles, right? So 120 plus 20, 140. So this is 40, right? Sum of these three must be 180. Now if this is 40 and this is 90 degree, this angle is 50 degree. Now sum of these three angles must also be 180. So 50 plus 70, 120. So this angle is 60. Now look at this triangle. Now look at this triangle. In this triangle we can apply the sine rule, right? We need to find IA by IB. So I can say that IA divided by sine of the angle opposite to IA, which is 70 degree, equals to IB divided by sine of the angle opposite to IB, which is 50 degree. Okay, so IA divided by IB is equal to sine 70 by sine 50. So this is the sine rule. Okay. So from here we got IA by IB. So now put the values here. VA divided by 5 meter per second, right? The velocity of B 10 meter per second equals to sine 70 by sine 50. So we got the value of VA 10 sine 70 divided by sine 50. We got 12.27 meter per second. So this is the velocity of A. I hope you liked this question. I hope you liked the solution. So moving on to the next lecture. So today we are going to start kinetics of particles. Now in kinetics of particles, we are going to see three different methods of solving the problems. D'Alembert's method, work energy method, and impulse momentum method. Let's understand what are these three methods, how we are going to use them to solve the problems of kinetics. Understand. See, mechanics is divided into statics and dynamics. Statics means the study of bodies at rest, and dynamics means the study of bodies in motion. Not exactly bodies in motion, we can say that it is the study of bodies which have accelerated motion. Okay. Now dynamics can be divided into two parts, kinematics and kinetics. In kinematics, we study the bodies in motion without considering the forces. So here we are only concerned with the motion variables. We are not bothered with the forces acting on the body. Here we got some equations between motion variables. We got some relations between motion variables, and we were using those relations in order to calculate the unknown motion variables. For example, V equals to ds by dt, A equals to dv by dt, A equals to v dv by ds. Then if there is uniform acceleration motion, V equals to u plus at, S equals to ut plus half at square, V square minus u square equals to 2s. All of these are the relations between motion variables. Some motion variables were known to us and some motion variables were unknown to us. So we were using only these relations between motion variables to solve the problems. Here we never needed forces acting on the body to calculate motion variables. But let's say there is a problem where you need to find motion variable, but just using these equations between motion variables, you are not able to solve the problem. For example, let's say you want to calculate the acceleration, but using the relations between motion variables, you are not able to calculate the acceleration. Here you will need to find the relation between force and motion variable. So in kinetics, what do we do? In kinetics, we study the bodies in motion, but here we will also consider the forces acting on the body. Why? Because in some cases we need to calculate the forces, and in some cases we need to calculate the motion variables, but those motion variables cannot be calculated without considering these forces. For example, acceleration, you are not able to calculate in a problem without considering the force. So that comes under kinetics. Okay. Now here we cannot find a definite difference between the problems which comes under kinematics and the problems which comes under kinetics. It's impossible to have a thumb rule that this problem, if these types of problems are there, they will be in kinematics, and if these type of problems are there, they will be in kinetics. No. Until and unless you see a problem and you try to solve the problem, you will not be able to understand whether it will be in this category or this category. Okay. But you don't have to worry about that. Okay. If you get a question from dynamics in GATE na, just by looking at the problem, you will be able to understand, okay, this problem will be solved using the concepts of kinematics. This problem will be solved using the concepts of kinetics. It all depends upon your practice. Okay. Now, motion is divided into three types: translation, rotation, and general motion. And I told you that if there is rotation involved, then we need to consider the entire body. Otherwise, we can consider the body as a particle. Okay. Particles only have translation. Particles cannot have rotation or general motion. Okay, so this is kinetics of particles. So here beta, the body will have only one type of motion, which is translation. When we will study kinetics of rigid bodies na, then we will consider translation, rotation as well as general motion. A rigid body can have all these three motion, but a particle can have only translation. It cannot have rotation, it cannot have general motion. Okay, chalo. So moving on to the kinetics part. So here what is our objective? Understand, in problems of kinetics, you will have to find the relation between forces and motion variables. What are the motion variables? V, S, A, T, all these are motion variables. Okay, so we have seen how to find the relations between these motion variables, right? We know the relations between these motion variables. Now we will see how to find relation between forces and motion variables. Now when we will solve problems of kinetics, we will use both these things. We will use the relations between the motion variables, V equals to U plus AT, S equals to UT plus half AT square. We will use these equations which we have used in kinematics. And we will also use the relation between forces and motion variables. Relation between force and velocity, relation between force and acceleration, relation between force and displacement, relation between force and time. We will use all these relations. Okay, so it can be said that it is a combination of statics and kinematics. Why combination of statics and kinematics? In statics, whenever we were used to solve a problem, we were used to draw the free body diagram first, right? So here also you will do the same thing. Here also, in every problem, the first step will be drawing the free body diagram. So this is part of statics. Okay, then we will use the concepts which we have used in kinematics, means relations between motion variables. V equals to U plus AT, S equals to UT plus half AT square. So this is a combination of statics and kinematics. Okay, you will need the concepts of both. Now, here we have three different methods to establish relation between force and motion variables: D'Alembert's method, work energy method, impulse momentum method. Now, you can solve any problem of kinetics using any one of these three methods. See, these three methods will give you almost the same thing, just the point of view is different. Okay, the equation that you get from these three methods are almost same, only a few changes are there. So in a problem you will either use this method or this method or this method. In a particular problem you will not need to use 2 or 3 of these methods, only one method. But in which case, which method you are going to use? So there is no thumb rule that if you get a question like this, apply this method. If you get a question like this, apply this method. No, it depends upon the question. Okay, we will solve multiple variety of problems and we will use different methods in different problems. Once you go through all these varieties, you will understand in which case which method will be effective, which method is better. But you can solve any problem using any method. In some cases, D'Alembert method is better, means it will give you the answer quickly. In some case, this will be better. In some case, this will be better. Okay, so how you will decide that? Based on the practice. Okay, so first what we are going to do is we are going to see all these three methods one by one, and then we will solve all the problems, and judging by the question we will choose which method we are going to use. Okay, so the first method that we are going to understand is D'Alembert's method. Now D'Alembert's method is based on the Newton's second law of motion. Understand, let's say that there is a body which is subjected to different forces. Okay, there are different forces, F1 is there, F2 is there, F3 is there, different forces are acting, and due to all these three forces, this body is moving in x direction. It is having acceleration in x direction. Okay, now what is the Newton's second law of motion? According to Newton's second law, F is equal to ma. Means if you apply a force F in a particular direction, there will be acceleration A in that direction. But here we are applying three forces, F1, F2, F3. But the acceleration is in X direction. It means the net force, the resultant force is in X direction. Okay. So here beta, summation of F is, let's say, net force in the direction of motion. Okay. Right now that direction is X direction plus X direction. Okay. So what we are going to do is we are going to find the net force in plus X direction. So we will resolve F1, F2, F3. You can see that the horizontal component of F1 is in plus X direction. So this force will be considered positive. Horizontal component of F2 is also in plus X direction. So this will also be positive. But horizontal component of F3 is in minus X direction, means opposite to motion. So this will be considered as negative. Okay. So we will calculate summation of F, net force in the direction of motion. So now the equation becomes summation of F equal to ma. Now you can use this equation to solve the problem. You got the relation between the force and motion variable, na? But this is not actually the D'Alembert's method. This is the Newton's law. You can use this. But what D'Alembert said is, if there is a body subjected to forces and it is having acceleration in a particular direction, you can apply an opposite force to the direction of motion, a dummy force which is opposite to the direction of motion. This is the dummy force, which can be written as ma. Okay, you can apply a dummy force which can be written as ma. Let me write it in different page. Okay, this is F1, this is F2, this is F3, and it is having acceleration in X direction. So right now it is a problem of dynamics. But if I apply a dummy force opposite to the direction of motion, opposite to acceleration A, and this dummy force is ma, so now it becomes a problem of statics. Okay, now it becomes a problem of statics, means now I can apply summation of fx equals to 0. It has become statics problem, na? So now I can apply summation of fx equals to 0. I hope you understood this. So what is D'Alembert's method? D'Alembert's method says that you can convert any problem of kinetics into an equivalent problem of statics by applying a dummy force ma opposite to the direction of motion. Now understand this. You will not need this method in kinetics of particles. See, in kinetics of particle, na, you can use this Newton's law, summation of f equal to ma. You will not need this. You will not have to apply a dummy force and then summation of fx equals to 0. Both will give you the same thing, but understand what I am trying to say. Even if you write it like this here in kinetics of particle, there will be no problem. But in some problems, you will have to use the D'Alembert's method. You will not be able to use the Newton's law. You will have to use the D'Alembert's method. And those problems we will see in kinetics of rigid bodies. Here you don't need to worry. Here you can apply the Newton's law, summation of f equal to ma. You don't need to worry about this dummy force and all. But when we will study kinetics of rigid bodies, na, there I will tell you why you are not going to solve the problem using this, why you will have to use the dummy force wala concept. I will explain. Okay. So right now you forget this, you just focus on Newton's law, summation of f equal to ma. Okay. So this is the first method. Second method is work energy method, which is actually based on conservation of energy. Not exactly conservation of energy. Understand here what happens. Whenever you apply force on the body and the body is displaced, you are doing some work on the body, right? That work is converted into energy. So the energy of the body is changed. What energy? Kinetic energy. If I apply a force on the body now, then the kinetic energy of the body is going to change. If I am applying the force in the direction of the motion, kinetic energy is going to increase. If I apply the force opposite to motion, kinetic energy is going to decrease. Why? Because of the work done. Okay. Now understand. Here we can use this concept. Work done is equal to change in kinetic energy of the body. Now understand, in case of translation motion, all the particles are moving with the same displacement, right? So let's say I am applying a force F1 at this particle, I am applying a force F2 at this particle, I am applying a force F3 at this particle. Now, due to the net force, this body is displaced by a distance s in horizontal direction. Now, how are you going to find the work done? Understand. Work done due to F1 will be the horizontal component of F1 multiplied by s, because this particle will have a displacement s. So work done due to F1 will be equal to the horizontal component of F1 multiplied by s. Similarly, work done due to F2 will be horizontal component of F2 multiplied by s. Similarly, work done due to F3 will also be horizontal component of F3 multiplied by s. Now s is common, so if you take s out, you will get horizontal component of F1 plus horizontal component of F2 minus horizontal component of F3, means you are going to get summation of f, right? So we can write this, summation of f into s. This is going to be the work done, net force in the direction of motion into s. Okay. Wait for the right time, we will launch everything. Crash courses, Abhyas batch, we will launch everything on YouTube, but on the right time. Okay. So this is the work done due to all these three forces. Now this work done is going to change the kinetic energy. Let's say it was moving with initial velocity u, and then due to all these forces the velocity became v. So what is the change in kinetic energy? It will be half m v square minus u square. So you got another relation between force and motion variables. In the last case, the motion variable was acceleration. Here the motion variables are displacements and velocities. Okay. Moving on to the next method, which is impulse momentum method. Now, in order to understand impulse momentum method, first you need to understand what is impulse and what is momentum. Impulse means what? It is the product of force and time. When it comes into picture, understand. Let's say I hit a body with a force and then I leave it. For example, let's say there is a box here. I hit the box, okay, I apply some force on the box and then I leave it. Means I am not applying the force continuously on the body. I just applied the force for some time and then I left it. So the force multiplied by the duration for which this force was applied. Let's say I applied the force for 1 second. The force multiplied by this 1 second is known as impulse. Okay. You can have different examples of impulse. For example, when you hit a ball with a cricket bat. So you are applying a force on the ball for some duration, right? For some instant, example 0.1 second. So force multiplied by that time is known as the impulse. Now what is the significance of this impulse? Understand. When you apply a force for a short duration, the velocity of the body changes, right? For example, let's say the box was at rest. Initially the box was at rest. So initial velocity was 0. Now when I pushed it for some time, let's say 1 second, I pushed it for 1 second and then I left it. I gave impulse to that box, and that impulse is going to change the velocity of the box from 0 to, let's say, 10 meter per second. Now there is a relation between the force and the impulse and this momentum. Understand from where this relation comes. This relation also comes from the Newton's law only. Summation of F equal to ma. Okay, understand. You can write A as dV by dt, right? Now if I move the dt here, I can write it like this: summation of F into dt equals to m into dV. Now integrate these equations. So let's say you are applying the force for t seconds. So the integration will be from 0 to t. And let's say the velocity changed from u to v seconds. So you will get this equation: summation of F into dt from 0 to t equals to m v minus u. Okay. Now what is this? What is this? This is known as the impulse, the product of force and time. And what is this? Mass into velocity. This is momentum. Mass into velocity is the momentum. mv minus mu is the change in momentum. So according to this relation, the impulse is equal to change in momentum. Now understand, if the force is constant, then this force will come out of the integration. If the force is constant, only then. If summation of F is constant, you are not applying a force as a function of time, your force is constant, then it will become this: summation of F into t equals to m into v minus u. In most of the cases the force is constant, but in some questions you will find that they have given the force as a function of time. F equal to 10t means the force is not constant, it depends on time. So in that case you will use this relation, but if the force is constant, you will use this relation. Okay, so this is the impulse and this is the change in momentum. According to this principle, if you apply external force for a short duration, it changes the velocity of the body, and the impulse of the force is equal to the change in momentum of the body. So I hope now you understand the relation between the significance of impulse and momentum. Thank you so much, buddy. Thank you so much, Robin. Thank you so much for the appreciation. I hope that your studies are going really, really well, and all the best for your future, all the best for your preparation. Thank you so much. Chalo. So beta, we have seen all the three methods. Now the question is, which method are we going to apply in which case? So beta, I told you that you can use any method in any problem, in any case, but in some cases this Newton's law is better, in some cases work energy is better, in some cases the impulse momentum equation is better. So we will solve multiple variety of problems, and once you solve all these problems then you will be able to judge whether you have to use this method or that method or that method. Okay, chalo, let's start the series of problems. So this is the first problem, and this is an MSQ question. Let's understand. The 50 kg crate is projected along the floor. The 50 kg crate is projected along the floor with an initial speed of 8 meters per second. Okay. The coefficient of kinetic friction is 0.4 and G is 10 meter per second square. Which one or more of the following statements is or are correct? The first statement is acceleration of the crate is constant. What does this mean? Understand. If the acceleration is a function of time, it's not constant, and if the acceleration is not function of time, it doesn't depend upon any other variable, it's constant. So how do we find out whether the acceleration is constant or not? Let's apply D'Alembert's method and let's find the acceleration. So in order to apply any method, you have to first draw the free body diagram. That is the first step to solve any problems of kinetics. Just like statics, you have to draw the free body diagram. Now G is 10. So the weight will be 50 into G, means 500 Newton. Okay. This is 500 Newton. Now there will be a normal force like this. Okay. And there will be a friction force. So let's assume that it is moving towards right. Now some students ask me, sir, how can you say that it is moving towards right? If you want, you can assume it is moving towards left. It doesn't matter. Okay, your acceleration will remain same. The magnitude of acceleration will remain same. So beta, let's assume it is moving towards right. The friction force will be towards left, right? So the normal force is, let's say, N1. And what will be the friction force, beta? It is, the kinetic friction is 0.4. Now here we will use the coefficient of kinetic friction, okay, 𝐴 into N1. So this is the coefficient of kinetic friction. Now understand, the acceleration of the crate is constant or not. So how are we going to understand? Let's say it is moving towards right, na? So we can use the Newton's second law, summation of F equal to ma. Now A is towards right, horizontally right. So the force must also be horizontally right. What is the net force towards right direction? There is only one horizontal force, 0.4 N1, but it is not acting towards right, it is acting towards left. So it will be minus 0.4 N1 equal to ma, means 50A. Now how will you find out the value of N1? Understand, we know that the body is not moving in y direction. In y direction it is static, na? So we can apply summation of Fy equal to 0. In y direction there is no acceleration. In x direction there is acceleration. Summation of Fx equals to ma. In y direction the net force is 0. So beta, here you will get N1 equal to 500 Newton. Okay. So we have got the value of N1. Now we can put that value. So what will be the acceleration? Minus 4 meter per second square. This is the acceleration. Is it a function of time? No. For any time, this acceleration will remain same, na? Minus 4. What is the negative sign? What is the significance of negative sign? Negative means it is deceleration or retardation. Means the velocity of this crate will keep decreasing. Okay. So the first statement is correct. The acceleration is constant. It is not a function of time. Second statement is time required for the crate to come to rest is 2 seconds. So how will you find the time required for the crate to come to rest? We can use this equation. V equals to U plus AT. Now time required to come to rest means final velocity is 0. Initial velocity is 8 meter per second. Acceleration is minus 4. So from here t is 2 seconds. Means time required for the velocity to become 0 is 2 seconds. So this statement is also correct. Third statement, distance traveled by the crate before coming to rest is 8 meter. Distance traveled before coming to rest means the final velocity becomes 0. So we can use this equation, v square minus u square equals to 2s. So final velocity is 0, initial is 8, acceleration is minus 4. So from here you will get the distance traveled before coming to rest. It is 8 meter, right? So this statement is also correct. Last statement is distance traveled by the crate before coming to rest is 10 meters. So this is wrong. Now you can see that in problems of kinetics, we have used the relation between force and motion variables, and we have also used the relation between motion variables. This is the concept of kinematics, na? Once you got the acceleration, then you use the concept of kinematics. So you are using the relation between force and motion variable. You are also using the relation between motion variables. Okay. So this is kinetics. Let's move on to the next question. Now this is an NAT question, a very interesting question. A 60 kg woman holds a 9 kg package as she stands within an elevator which briefly accelerates upward at a rate of g/4. The force R which the elevator floor determine the force R which the elevator floor exerts on her feet during the acceleration interval. Means when this lift is accelerating, elevator means lift, when this lift is accelerating upwards, at that time what is the force acting between the feet of woman and the floor? See, if you are standing on the floor, you are applying some force on the floor, and the force is applying equal and opposite force on your feet. There is equal and opposite force between your feet and the floor, na? You are applying downward force on the floor, and the floor is applying equal and opposite force on your feet upward. So first we will draw the free body diagram of the woman. Look at this. The woman has a weight of mass of 60 kg, G is 10. So the weight of woman is 600 Newton. But she is also holding a package of mass 9 kg. So that will also be added. So total mass is 69. So total weight will be 690 Newton, right? I have added the mass of the woman as well as the package. Now the woman is applying downward force on the floor, so floor must be applying equal and opposite force on the woman. So let's say this force is R. So this is the free body diagram of the woman holding the package. Now this woman is accelerating at a rate of g/4 upward. She is standing in the elevator, right? And if the elevator is moving upward with an acceleration g/4, the woman is also moving upward with an acceleration g/4. Means 10/4 means 2.5. Okay. Now what do you need to calculate? You need to calculate R. So you can apply D'Alembert's method or Newton's second law, summation of F equals to ma. Now here your A is upward, vertically upward. So your net force must also be vertically upward. So what will be the net force in the direction of motion? R minus 690. It will be R minus 690. Okay. M will be 69. Acceleration is 2.5. So from here you will get the value of R. 69 into 2.5 plus 690. You are getting 862.5 Newton. So this is the force acting between the woman and the floor. Now let me explain this. What is this force? Why they are asking you to calculate this force? Understand. This is the effective weight of the woman. Actual weight of the woman is with the package is 69 kg. Okay, including the package, actual weight is 69 kg. But if the lift is accelerating upwards, the weight of the woman increases from 69 to 86.25. The weight is increased from 69 to 86. Okay, why? Because of this upward acceleration. You might have felt this when you are standing in a lift. If the lift moves upward, then you feel heavy, and if the lift is moving downward, then you feel lighter. It is because of this acceleration. Okay, so the same problem can also be asked in a different way. For example, they can ask you, what will be the effective weight of the woman if the lift is moving upward with the acceleration of g/4? So how will you calculate this effective weight? Simple. See, what is the weight? It is the force acting between you and the surface you are standing on, right? That is the weight, na? What is the weight? Whatever force you are applying on the surface, that is your weight. How do you measure weight? You stand on the weighing machine. Means you apply force on the weighing machine, and then weighing machine reads that, calculates that weight, how much force you are applying. It calculates that. So if she stands on a weighing machine, which is inside the lift, then on that weighing machine she will apply this much amount of force. So her weight will be 86.25 kg or 862.5 Newton. Okay. Chalo. Moving on to the next question. Now this is an interesting question. The 10 kg block is moving to the right at 5 meter per second when the 200 Newton per meter spring is unstretched. Means right now this block is moving at 5 meter per second and the spring is unstretched. Now what will happen? As this block starts moving, the spring will start deforming. If the horizontal plane is frictionless, the block will travel a distance of how many meter before coming to rest? See, understand, when this block will start moving towards right, the spring will start deforming, but the spring will oppose this deformation. Means the spring will try to pull this body back by applying spring force. So this velocity of the block will start decreasing. Right now it is 5 meter per second when there is no deformation in spring, but as it starts moving, deformation in spring will start increasing and the velocity of block will start decreasing. After a certain point, the velocity of block will become 0. So they are asking you, what will be the distance traveled by this block when the velocity becomes 0? Let's say the distance traveled by the block before coming to rest is x. So the deformation of spring will also be x because it is attached to spring, na? So if it moves by 1 meter, spring will deform by 1 meter. If it moves by 2 meter, spring will deform by 2 meter. So if it moves by x meter before coming to rest, spring will deform by x meter before coming to rest. Now understand a very important concept here. Here they are saying that the plane is frictionless. Whenever there is relative motion between body and the surface, whenever the body is moving on the surface and they are saying that the surface is frictionless, you can use conservation of energy. What is conservation of energy? Initial energy equals to final energy. There is a difference between work energy and conservation of energy. Work energy method is applicable everywhere, whether there is friction or no friction. But conservation of energy means initial energy equal to final energy is only applicable when there is no friction. Now, which energy will you take in conservation of energy? Both potential energy as well as kinetic energy. In work energy, the energy that you are considering is only kinetic energy, no potential energy. But conservation of energy means total energy, potential energy as well as kinetic energy. So here understand this. Let's say this is your surface, okay, and let's say this is the spring connected to the box. Now this is the initial state. Initially the velocity of the block is 5 meters per second. Now this block moves, let's say, by x distance when the velocity becomes 0. Okay, so this is the initial state and this is the final state. Okay, let's say this distance is x meter. So I can apply conservation of energy. Why? Because there is no friction. Now conservation of energy means the energy will always remain constant. Whatever energy was there at this state, it will be same at this state. So I can say that E1 is equal to E2. Okay. Now what is the energy in the first state? So when the block was here, the spring was undeformed, means there was no energy in the spring. The energy of spring was 0, but the block was moving with 5 meters per second. So there was kinetic energy in the block, right? But when you got to the second phase, the second position, the velocity of block became 0, means the kinetic energy of the block became 0, but now the spring is stretched by x meter, na? Block is moved by x meter means spring also stretched by x meter. So now there is potential energy in the spring. What is the potential energy of the spring? Half kx square. Half and half will be cancelled. What is the mass of the body? 10 kg. U is 5 and K is how much? 200 Newton per meter. K is 200 Newton per meter. You have to use everything in SI unit. So K must be in Newton per meter. Okay. If it is not in Newton per meter, you will have to convert it in Newton per meter. So now we will get the value of X in meter. 1.118 meters. So this is the distance traveled by the block before coming to rest. Okay. Now if there was friction in the box, then you will not be able to apply conservation of energy. Then you will have to apply work energy. How will you use work energy? See, everything will remain same, only what happens is now you will have to consider the friction force. So friction force will become minus mu n multiplied by distance x. This will give you the work done equal to change in energy. But when you will consider the energy, you will write the change in kinetic energy of the block, also the energy of the spring. Whenever there is a spring attached to the body and you are using work energy, then the change in energy will be half mv square minus u square plus half kx square. Okay, you will also have to consider the energy of spring. Okay, chalo. Moving on to the next question. A block of mass 20 kg was initially stationary on an inclined plane. Coefficient of friction is 0.4. The body slides down the plane and attains a velocity of 10 meters per second. Distance traveled along the plane is. Look at the question. Which method are we going to use? Understand the motion variables mentioned in the question. They have mentioned velocity and they have mentioned distance. So which equation are we going to use? Of course, work energy, na? Velocity and displacement, both are there in work energy. You can use D'Alembert's also. You can calculate the acceleration and then use the relation between velocity, acceleration and displacement. V square minus U square equals to 2as. But we can directly use work energy and calculate the value. But in order to do that, we need to first draw the free body diagram. Now, whenever the body is on inclined surface, I told you, always resolve the forces parallel to the surface, normal to the surface. Weight will be 200 Newton. So this will be the cos component of weight. This will be the sine component of weight. What is the value of theta? 30 degree. This is going to be 200 cos 30. This is going to be 200 sine 30. This is going to be the normal force and it is moving downwards. So friction force will be this. So this is going to be N1 and what will be the friction force? 0.4. So my 0.4 N1. Okay. Now we are going to use work energy. First we have to calculate the net force in the direction of motion. In this direction there is no motion. In this direction net force is 0. So you can say N1 will be 200 cos 30, right? Net force in this direction must be 0. In this direction body is not moving. Body is moving in this direction. Now what is the net force in the direction of motion? 200 sine 30 minus 0.4 N1. 0.4 N1 is opposite to motion. So summation of F will be 200 sine 30 minus 0.4 into 200 cos 30. So summation of F will be equal to how much? 30.72 Newton. 30.72 Newton. So this is the net force in the direction of motion. So now we will apply work energy equation. Summation of F into S equal to half mv square minus u square. So they are saying that it slides down from rest and attains a velocity of 10 meter per second, means u is 0, v is 10. Distance traveled along the plane is how much? So they are asking S. So 30.72 sorry multiplied by S equal to half into 20 into 10 square minus 0. From here you get the distance S. So you are getting 32.55 meters. So this is the net force, the displacement along the plane before when it attains a velocity of 10 meter per second. Let's move on to the next question. Now this is an MSQ question and it is a very interesting question. Understand. An inextensible massless string goes over frictionless pulley. Two weights of 80 Newton and 120 Newton are attached to the two ends of the string. The weights are released from rest and start moving due to gravity. Assume G equal to 10. Which one or more of the following statement is or are correct? Tension on both sides of the string is same. Understand. If there is no friction between the pulley and the rope, then tension on both sides will be same. if there is no friction between the pulley and the rope, tension on both sides will be same. So this option is correct. Acceleration of 120 Newton block will be greater than 80 Newton block. Is this correct? Understand. If I move 120 Newton block by x distance, 80 Newton block will also move by x distance, right? They are connected in such a way that if I move it by x, this will also move by x, right? Means the displacement of both these blocks is same, just opposite, but the magnitude will be same. And if the displacement is same, then the velocity will also be same. If x is same, dx by dt will be same. And if the velocity is same, acceleration will also be same. Means d square x by dt square will also be same. It means that the acceleration of 120 Newton block and 80 Newton block will be same. So this option is correct. Sorry, incorrect. Maximum tension in the string is 96 Newton. See, both will have the same tension. So we'll have to calculate the tension, and acceleration of 80 Newton block is 2 meter per second square. So you have to calculate acceleration. Now how will we solve this? Understand. First of all, you know that this block will move downward and this block will move upward. See, it is the heavier block, na? 120 Newton is heavy, so it will move downward. 80 Newton is lighter, it will move upward. Now I will draw the free body diagram of 80 Newton and 120 Newton. What I will do is, I will cut this string like this. I will draw the free body diagram of 120 Newton and 80 Newton block. Here. This is moving downward, this is moving upward. So if I cut it like this, how the free body diagram will look, understand. This is the 80 Newton block and this is the 120 Newton block. So this is the weight 80 Newton, this is the weight 120 Newton. Tension will be same on both sides. $80 Newton and T. 120 Newton and T. Now acceleration of both the blocks is same. This is moving downward with acceleration A. This is moving upward with acceleration A. Now we will apply summation of F equal to MA on both the blocks. For the first block, the net force will be upward. So it will be T minus 8T equals to 8A. Mass will be weight by G, na, 8A. And second, 120 minus T will be equal to 12A. Now look at this. If I add both of them, this is equation number 1 and this is equation number 2, na? So if I add equation number 1 and equation number 2, what I will get? T and T will be cancelled. 120 minus 80 will become 40 and 8A plus 12A will become 20A. So A will become 2 meter per second square. So acceleration we have got. Now put this acceleration in any of these equations. T minus 80 equal to 8 into 2. So T will be equal to 96. So the tension is 96, acceleration is 2. So this is correct. This is also correct. So A, C and D are the correct answers. B is the wrong answer. Okay. Now let's move on to the next question. And this next question is very interesting. Understand why. First of all, I have to make a small change, okay? Let me make it 30 kg. Okay. Now understand. Here you have two blocks, 10 kg and 30 kg, but they are not connected by a single pulley. They are connected by two different pulleys. So here what is happening, understand. First of all, the heavier block will move downward. This will move downward and this lighter block will move upward. So this is easy. But you will see that if I move this 30 kg block by x distance, this 10 kg block will not move by x distance, right? If you apply a little bit of logic, you will be able to find out if I move this body by x, how much this body will move. But what happens is this imagination is not easy. A lot of people get confused. So I will give you a very simple method to find if this moves by x, how much this will move. Understand. Let's say this is tension T. Let's say this is tension T. So this will be tension T, this will also be tension T. See, there is no friction. So tension will be same in the entire string. This is a single string. Okay. Now if this is T and this is T, this is 2T. Now understand. You have to use this concept. Tension into acceleration must be same for all blocks. Tension into acceleration must be same for all blocks. If this block is moving with an acceleration A, then this block will move with an acceleration 2A. Can you see? Tension into acceleration must be same. So 2T into A, 2TA, and T into 2A, 2TA. So tension into acceleration must be same. Okay. That you need to just understand. If you do this, you will be able to find out the relation between acceleration in every case whenever there are more than one pulleys. Okay. So now we know that 30 kg block is moving downward with acceleration A. It is subjected to 2T tension, and 10 kg block is moving upward with acceleration 2A. It is subjected to T tension. You need to find the tension in the string. So how will you do that? Again, you will do the same thing. You will draw the free body diagram of both the blocks. Okay. So 10 kg block and 30 kg block. 100 Newton T, 300 Newton 2T. This is moving down with acceleration A, this is moving up with acceleration 2A. Now I will apply summation of F equal to MA for both the blocks. This block is moving upward, so net force will be T minus 100 equal to mass 10 into acceleration 2A. This block is moving downward, so it will be 300 minus 2T equal to 30 into A. Now, by solving equation number 1 and equation number 2, you can easily find the value of T. So tension is 128.57. Acceleration is 1.428. So this is the tension T in the string. Okay, 128.57 Newton. Okay, now moving on to the next question. Now this is a very interesting question. Understand this question. A block of mass 5 kg resting on a 30-degree inclined plane is released from rest. After traveling a distance of 0.8 meter along the plane, the block hits a spring of stiffness 1 Newton per mm. Find the maximum compression of the spring. Assume coefficient of friction 0.2 and g equal to 10 meter per second square. What is happening is we are releasing this block from rest. It moves by a distance 0.8 meter and then it hits the spring. Now, when it will hit the spring will start getting compressed. They are asking what is the maximum compression of the spring. So first you need to understand the condition of the maximum compression. When it will hit the spring will start getting compressed. Why? Because this block is giving the spring its energy. The block is giving some of its energy to spring. So kinetic energy of the block will start decreasing, potential energy of the spring will start increasing. Means velocity of the block will start decreasing and deformation of the spring will start increasing. Now the spring will keep on getting compressed until and unless the block comes to rest. This block will keep on compressing it. How much it can compress the spring? Until it has some energy, right? When the velocity of the block will become 0, the energy will become 0. So now it cannot compress the spring anymore. That will be the maximum compression of the spring. So maximum compression of the spring will be when the velocity of the block will become 0. So understand what you need to do here. Here, this block is moving with initial velocity 0, and when the spring will get compressed maximum, then the velocity of the block will also become 0. Means initial velocity and final velocity both are 0. Okay. Now you have to apply work energy theorem. Okay. So first of all, let's draw the free body diagram of the block. So this will be the weight, this will be the normal force, and this will be the friction force. What is the weight of the block? 50 Newton. So this will be 50 cos 30, 50 sin 30. This is N1 and coefficient of friction is 0.2. So this is 0.2 N1. Okay. Now, what is the net force in the direction of motion? 50 sin 30 minus 0.2 N1. N1 will be equal to 50 cos 30 because the block is not moving normal to the plane. It is moving parallel to the plane. And the net force in the direction of motion will be 50 sin 30 minus 0.2 N1. We have already seen this, right? 50 sin 30 minus 0.2 into 50 cos 30. So net force in the direction of motion is 16.34 Newton. Okay. Now, we will apply the work energy equation between this state and when the spring will get compressed maximum, means when the block will come to rest again. So summation of F into S will be equal to half mv square minus u square plus half k x2 square minus x1 square. What is x1? Initial compression. What is x2? Final compression. Okay. Now net force in the direction of motion is 16.34 Newton. What will be the total distance traveled by this block? First is traveled by 0.8 meter, na? And then it traveled by some distance. How much? Delta maximum. This is the maximum deflection of the spring, equal to half m v square minus u square. Now both v and u are 0, okay, into half k. K is how much? 1 Newton per mm. Now you have to convert the Newton per mm to Newton per meter. So it will be 1 into 1 by 10 to the power minus 3 Newton per meter. Na? 1 mm is 10 to the power minus 3 meter. So it will be 1000 Newton per meter. Now finally the spring will be compressed by delta max, and initially it was not compressed. Now why I have written it like this? Because in some question they will give you the initial compression of spring, that the spring is initially compressed by this much. In this particular question and in the question we solved previously, initial compression was 0, initial deformation was 0, but maybe in some case there will be initial deformation. That's why I have written it like this, half k x2 square minus x1 square. Now if you solve this equation, you will get delta maximum. This will be a quadratic equation, okay? It will become a quadratic equation. Let me write the quadratic equation. It will become 500 delta max square minus 16.34 delta max minus 16.34 into 0.8 means 13.072 equal to 0. So this is a quadratic equation. If you solve this quadratic equation, you will get the value of delta max. See, you are getting two values of delta max. One is positive, one is negative. You have to use the positive value only, because delta max is actually considered as a distance. See, this is a distance, na? Don't think that compression means negative. See, here you have written delta max as a distance. So if delta max is a distance, it cannot be negative. Okay. So that's why you have to use the positive root only, 0.18 meter. Let's move on to the next question. Now this next question is very interesting. Understand. If motor exerts a force of 10t square plus 100 Newton on the cable, determine the velocity of the 25 kg crate when t is 4 seconds. See, this motor is applying some force on this crate, and that force is a function of time, 10t square plus 100. Now, coefficient of static and kinetic friction are 0.3 and 0.25. Crate is initially at rest. Assume g equal to 10 meter per second square. Understand? Here, you are applying a force on this crate for pulling this crate, but that force is not constant. It is a function of time. You want to calculate the velocity after 4 seconds. So here you have to apply impulse momentum equation. But there is a very interesting concept here. In this question, they have given you the static and kinetic coefficient of friction. In all other problems, they have given you only one coefficient of friction, kinetic coefficient of friction. But here they have given you both. Why? The reason is the force is a function of time, means it is not constant, it is varying. Initially the force will be less and then it will increase. After 4 seconds, at t equal to 4, whether this force will be enough to move the crate or not, that you have to calculate. See, if you want to move this crate, the force applied by this should be greater than mu s into n. Mu s into n is the minimum force required to move any body, right? So if this force is not greater than mu s into n, the crate will be at rest at t equal to 4 and your answer will be 0. So that's why they have given you the static coefficient of friction. You need to check. Okay. Chalo, let's check. So we will first draw the free body diagram of the crate. Now this force, let's write it P, because F is the friction force, na? Let's write it P. So you are applying a force P here, and this will be the friction force. Okay. Right now you don't know whether the crate is moving or not moving. So right now you will write the friction force as F. What is the weight of the crate? 250. So first you will calculate the maximum friction force that this crate and the surface will have. N1 will be equal to 250 Newton because the crate is not moving in Y direction, right? Maximum friction force which you have to overcome in order to move this is how much? F maximum is 75 Newton. So the crate will move only if you apply more than 75 Newton. Now understand here. This P at t equals to 4 second will be more than 7. At t equals to 0 second only, it is more than 75. Na? At t equals to 4, P will be equal to 10 into 4 square plus 100. Means how much? Sorry. 10 into 4 square means 160 plus 200, 260 Newton. So P is greater than F maximum, means at t equals to 4 seconds, the crate is moving. It is proved. If let's say your P was only 60 Newton, then your answer would have been 0. Because in order to move the crate, you need more than 75 and you are applying only 60. So the crate will not move. But now we know that the crate is moving. But whether it is moving from 0 to 4 seconds or whether it is moving from 1 second to 4 seconds, whether it is moving from 2 seconds to 4 seconds, that also you need to understand. So the crate was moving from t equal to 0 only, because at t equals to 0, P was at t equals to 0, P was 100 Newton. Na? So P was greater than F maximum, means crate is moving from t equal to 0 to t equals to 4 seconds. Now why we are doing it, you will understand later. Maybe in some question crate will not move from the start, maybe it will move after 2 seconds. Let's say for example the force P was 10t square plus 20. Let's say the force was 10t square plus 20. So at t equals to 0 seconds, the force will be only 20 Newton, right? So it will not move at 0 seconds. At t equals to 1 second also, it will be only 30 Newton. So it will not move. At t equals to 3 seconds, what will happen? Yes. So at t equals between 2 seconds to 3 seconds, somewhere between 2 seconds to 3 seconds, the crate will start moving if the force was 10t square plus 20. So you will calculate that time, and then from that second to 4 seconds, the crate will move. Now why we are calculating this time, understand. Because we will have to use the impulse momentum equation and we will have to integrate, because right now the force is not constant. Na? So what will be the limit of integration? Right now the limit will be t equals to 0 to t equals to 4. But let's say the crate was not moving from 0 to 2 seconds. It started moving from 2 to 4 seconds. Then the integration will be from t equals to 2 to t equals to 4. So that is why we were calculating it. So understand, the force will be how much? 10t square plus 100 minus mu k into n. Now the force will be mu k into n. Na? So 𝐜𝐾 is how much? 0.25. N is how much? 250. So friction force you also have to consider. Okay. So 10t square plus 100 is acting this side, friction force is acting this side, and now we know that crate is moving. So here there will be 𝐜𝐾. So it is 𝐜𝐾 into N equal to the weight of the mass of crate is how much? 25 kg. Final velocity we need to calculate. Initial velocity is 0, and this will be integrated from 0 to 4. So now we will get the velocity V. The velocity is 14.53 meter per second. Okay. So this is how you can solve these type of problem. There was a question like this in gate mechanical. Okay. So there the block was not moving from 0. The block was moving after, let's say, 2 seconds or 3 seconds. So the integration limit will change. Here in this question it is moving from 0 to 4 seconds. So your limit was 0 to 4. If it is moving after 2 seconds, so it will be 2 to 4. Okay. Now this next question is a very interesting question, but this is your assignment. I want you to solve this question on your own, and in the next class we will see the solution of this question, and we will also see kinetics of rigid bodies. Thank you so much. I will see you in the next class. Till then, bye bye. Take care. Good night.